Hello, welcome to 4.4, Understand Slope of a Line. We have three objectives. Use m equals rise over run to find the slope of a line from its graph. Find the slope of horizontal and vertical lines, and use the slope formula to find the slope of a line between 2 points. So let's look at the definition of a slope of a line. Slope of a line simply means the slantness of a line, okay? I'll just write that here, slantness. So when we talk about the slantness of a line, we tend to think of some kind of an angle or so, right? But what we realize is we could do this without actually talking about the angle. We could actually look literally outside the box by looking at the rise over run. We're going to see what that means. Rise simply means the vertical measure, the vertical change, okay? So I will just write here, vertical change over horizontal change. Horizontal change. Change means difference, right? Change. Something changed. So there was a difference. Vertical change means you take the difference of the y values, because y is the vertical axis, right? So that's the difference in y values over difference in horizontal is x, so in x values. That's the definition that builds up from there, okay? But rise over run is a very easy catchphrase for us to remember that is our slope. So the way we find the slope of a line from the graph is to locate 2 points on the line and then locate good points so that you have them as proper integers, and then use that to draw a sketch of a right triangle. I think it'd be easier if I showed you what I was meaning. Let's take this line, okay? This line slants like this. We want you to take good points. Again, I'm not drawing this on a grid, so you really can't determine what is a good point, okay? So what they're saying is get 2 points on the line and start with a point on the left, okay? Let's use this point. Sketch a right triangle going from the first point to the second point. So this is my blue point. I want to draw a right triangle, so it has to make 90 degrees. So I try to form a right triangle. I'm having some difficulty with that. That wouldn't move. Doesn't move finely. You know what? I'll just do it by hand. That was better. Okay, so I made a right triangle. I know that I made a right triangle because the horizontal and the vertical meet at 90 degrees. And that's all they're saying. They're saying this is the rise and this is the run. In a grid, you can actually count the rise by counting how many boxes it rows, and you can count the run by counting how many boxes happens on the horizontal distance. And then if you take the ratio, if you took the fraction of those two, that gives you the slope. Isn't that cool? You really don't have to carry a protractor or any other equipment to really do this. You just have to understand what the rise over run is. So that is literally drawing outside the box to understand the slantness of a line. So let's look at this problem. Find the slope of the line shown. Okay. So now we have a line very similar to the one I drew, but this one is on a grid, so it makes it even more easier. Okay. Okay. Let's say you chose. They said choose any 2 points, right? Nice points. Do you think this is a nice point? Can I find the coordinate for that? No, because it's really not sitting at the intersection of a box. So that is not a good one. How about this point? Bad one. So you really are looking for points where they will pass through that intersection of a box. You see that? A corner of a box, right? That's a good point. This one is not good, but this one is, right? I like these 2 points because I can actually write the coordinate, right? For the others, it's very hard to write the coordinate. So this is nice because it's 5, and it hits at 1. And this would be 0, -3. Right? Nice points. If I'm able to write the points as integers, it's a good point. But that was just to see if we chose the right points. But what we're trying to do here is to make a triangle, a right triangle out of this. With a grid, it's a lot easier, right? So we made a right triangle. They want us to count the number of boxes as rise over run. So I'm just going to quickly count with you. So we have 1 box, 2, 3, 4. We have 4 boxes that we crossed to mark the vertical line. And let's count how many boxes on the horizontal. 1, 2, 3, 4, 5. So our rise is 4 boxes, and our run is 5 boxes. So our slope is rise over run, which means you need to have 4 over 5. So the slantness of the line is 4 over 5. Okay, that's it. It's a number. It's not a degree or an angle. It's a number. In fact, when we do a look at application problems, we'll be able to interpret this number much, much, much better. Right now, it looks like a plain number, and it doesn't seem like the slantness of a line, which is okay. Okay, we're just learning the concept, so we don't see the full picture yet. So I just want you to remember that slope is a number. Okay, it's not an angle. It's not a degree. It doesn't have x or y. It is a number. Let's talk about slope of a horizontal line. Okay, so you have a horizontal line. Okay, we're looking for the slantness of this line because slope of a line has a slantness. What is the slantness? So think of this horizontal line as your floor, right? Most of our floors are horizontal, they're flat. So if you put a ball on a floor, it doesn't roll off, right? So because there is no slantness. Therefore, understand that slope of a horizontal line is 0. Oh, by the way, the slope is, we use the letter M for the slope, so I used the letter M. But I will introduce it to you formally when we look at the formula. So the slope is, so I'll perhaps remove the M. The slope is 0 for a horizontal line, okay? What about a vertical line? A vertical line has what kind of slope? Okay, think of the vertical line as your wall, right? Could you even place a ball in order to make it roll, right? You can't even position the ball because you have to hold on to the ball from rolling off because it is too steep. So the slope of any vertical line is undefined. Okay, you need some kind of slantness. If it is it's erect, if it's vertical, we have really no discussion about the slantness. Therefore, the slope for vertical line is undefined. Okay. Horizontal line, the slope is always a 0. Vertical line, the slope is always undefined. And a quick connection with the lesson we learned previously. We have the equation of a horizontal line as y equals some number a, and the equation of a vertical line is x equals some number a. So even if you don't have a visual of a vertical or a horizontal line, but if you had a visual of the equation, you got the equation. Right by looking at the equation, you can already tell what the slope is. Okay? So here comes the quick guide. Okay? If your slope is positive, then your line rises from left to right. Let me write that out there. Okay? Left to right, line rises, right? You always read from left to right. You don't just do any direction. It's always left to right. When you look at your graph from left to right, this one falls. So the line falls, which means it has a negative slope. So because slope is a number, when it's rising, the slope will be a positive number. When the line falls, the slope will be a negative number. Left to right, no change, which means you have the slope as 0. And moreover, it's a horizontal line. So right away, you don't have to even scan the graph. You know that if it's a horizontal line, the slope is 0. And from left to right, if you look at this vertical line, there is no left to right, right? There's only top to bottom. So from left to right, there is really nothing that you could scan. And even otherwise, a vertical line always has undefined slope. Okay. So now let's come to look at the slope formula. Slope formula is a popular one because of its simplicity. Just like the Pythagorean theorem, it's very simple and it's very practical, it's very useful. Likewise, your slope formula is very, very useful. And this is where you see for the first time the slope formula having the letter M. Okay, we don't like to use English in math, for that matter, any language, right? Math itself is a language. So we simply use the letter M to indicate the slope, so that no matter what language we speak or where we come from, we can all understand the formula, because as long as we all understand that language of math. All right. So you have y2 minus y1 over x2 minus x1. That is the formula. But if you look at this is the same as your rise over the run. Your formula cannot change, right? It changes form, but it does not change in concept. So the rise is still your vertical change. I discussed that initially. Vertical change is the difference in the y's. That's what you have, the difference, right? y2 minus y1. And the run is the difference, or the horizontal change. So difference in the x's is x2 minus x1. You have to memorize the slope formula, because that's going to really help you with the rest of the chapter. So it's m equals y2 minus y1 over x2 minus x1. So again, when you have 2 points, okay, so I'm just giving you a line and there are just 2 points. And you don't have a grid like this, and you don't have a way to count how many boxes to go across, how many boxes to go up. So if that's the case, then we use the slope formula, because the slope formula, all it wants is the coordinates. It just wants x1, y1 and x2, y2. It doesn't, you don't have to really draw a triangle, a right triangle to complete finding the graph, because the slope, because you really don't have the grid, isn't it? So this is useful in many practical places, because you really don't have information on the grid, but you can find the coordinates, right? GPS and all that. So you can find the coordinates, so you can totally locate that and use that to find the slope. Okay. So use the slope formula to find the slope of the line between the 2 points, 1, 2 and 4, 5. All right, now we are not given the graph, but we are given the points. Okay. So you could choose any one to be x1, y1. You have 2 points, that's why we have the different way. It's simply x, y, but if I have 2 x, y's, then I have to have the confusion, right? Which x are you talking about? Therefore, we have the x suffix 1, y suffix 1 to indicate the first point, x suffix 2, y suffix 2 to indicate the second point. Now, if I have 10 points, I can do x1, x2, etc. up to x10, right? So we really like the idea of writing the suffix or the subscript, so that you could actually make a quick reference to the point. All right, so let me write the formula. Slope, maybe I write slope, equals m, which is y2 minus y1 over x2 minus x1. Okay, now go back and see what corresponds to y2. y2 is 5 minus y1 is 2 over x2 is 4 minus x1 is 1. You cannot switch the x's and the y's. The y's have to go on the top, the x's have to go on the bottom. You could switch them and still get some answer, but that won't be correct, right? Because it's a number, you might think, oh, it's a number, I got a number, so I'm fine. No, you need to get the correct number. Okay, so we have that. So 5 minus 2 is 3 over 4 minus 1 is 3, 1. So the slope is 1. This implies m is 1. Let's box that. Okay, what do you know about a positive slope? This is just an extension. We're done with the problem, just an extension. What do you know about a positive slope? This is a positive number, right? It's a positive 1. If the slope is positive, you will always see your graph rising, okay? That means your line is increasing. And so this implies the line is increasing from left to right. That is an extra information we found just by doing it by algebra. That's why we like algebra, So we could always come to strong conclusions about many things without really having to see them, right? We didn't see the line, but we already know how the line would be. It's going to be a slanted line. We don't know how it will slant. Actually, we do, because m equals 1 tells us exactly how it slants, but we don't know what that means yet. So we really don't know how it's going to slant yet, but we do know that it's going to rise from left to right. Okay. I hope that helps. We've reached the end of this section. I will see you in the next video.